Welcome back to Learn as you explore for another MBOT 2 tutorial. A couple of tutorials ago, we implemented the proportional control line follower along with color sensing and obstacle avoidance in Python. In that project, when the robot detects an obstacle, it would simply stop and wait for the obstacle to be removed. But what if the obstacle cannot be removed? The robot would just stay there forever, waiting for it to be moved. In this video, as well as next week's video, we're going to tell the robot what to do by tilting the robot. Tilting the robot to the left will make the robot turn left 90 degrees, drive straight until it reaches the line on the opposite side, and then continue line following. The robot will do a similar thing when tilted right, only it will turn right 90 degrees before driving straight. Today's video will be part A, where we will implement tilt detection and the first part of the reaction, the 90-degree turn. In next week's part B video, we will take this across the finish line by implementing the second part of the reaction, that is driving straight until a line is detected and then continue line following. Before we dive in, here's a quick way to support my work. If you're planning to get an MBOT too, you can use my Amazon affiliate link in the description. It won't cost you extra, but as an Amazon associate, I earn from qualifying purchases. Or if you just want to say thanks, there's a buy me a coffee link down in the description too. Alright, let's jump in. If you haven't watched my past videos that are related to today's project, check those out first. They will give you the foundation needed to follow along and implement today's project. Links to those videos are in the description. I'll also include the links to the Python API docs in the description. I hope you've already bookmarked them for easy access. Alright, without further ado, let's get coding. Open mblock and first let's load the Python program from tutorial 13. Select the program and click OK. Now let's make a copy before we edit the content of this program by clicking File, Save As. I'm going to call it tutorial 15, Advanced Line Follower plus Tilt Obstacle Avoidance Recovery. Say OK. First, since we're not interested in color sensing in this project, let's get rid of this part of the code. So select that and delete that. Now we cannot start off with an else if block, so this would just turn into an if block. Let's now introduce a new variable called recovery mode, and we will initialize it to none to indicate that there is no recovery to begin with. This means that initially the robot will be doing line following, so we're not really in any recovery mode. We will add a check to make sure that we're not in recovery mode before performing regular line following along with obstacle detection. So here we'll say if recovery mode is none, and we'll move all of the following lines within the while loop one tab over. So select the entire block and hit tab once to indent everything inside the if recovery mode is none statement. Now, let's say that the robot does detect an obstacle. We will come in here and we will stop all the motors. This is where we want to tell the robot to go into recovery mode. We will have two recovery modes. One will be left and the other will be right. We need to decide which recovery mode to go to. Fortunately for us, we can tell the robot which recovery mode to go to by tilting the robot in that direction. So here, we will check if the robot was tilted left by using the cyberpy.isTiltLeft API. And in this case, we will set recovery mode to be left. Else, if the robot is tilted right, which we'll check using the cyberpy.isTiltRight API, we will set the recovery mode to right. To define what we want to do in the recovery mode, let's add an else branch corresponding to this if recovery is none statement. If the program reaches this else part, it means that the recovery mode was set to some value other than none. It could be either right or left. The first thing that we want to do here is to wait for the robot to be placed back on a flat surface. This is because we don't want the robot to start the 90-degree left or right turn while we're still tilting the robot to signal which recovery mode it should go to. We want to start the turn only after the robot has been placed back on a flat surface. In other words, as long as the robot is tilted in any direction, we want to simply continue checking that it is flat. We'll add the condition here. If cyberpie.is tilt left or cyberpie.is tilt right or cyberpie.is tilt forward or cyberpie.is tilt back. This checks if we are tilted in any direction. If this condition is true, we simply want to continue. This continue statement will take us back to the beginning of the while loop. Since we still have recovery mode set to left or right, we will not go into this branch. We will come back to the else statement and continue checking if the robot is tilted in any direction. Only when there is no tilt in any direction, this condition will evaluate to false and we will move on to executing the next statements. Alright, so we are no longer tilted if we reach this part. First, let's wait for a couple seconds after placing the robot flat before starting the turns. To perform this wait, we will use the time.sleep API and we'll give it a time of 2 seconds to sleep. Time is a Python package that we can import using an import statement at the very top of our file. So say import time. This means that the code will pause here for 2 seconds before continuing. Once we've waited a couple seconds, let's execute the turn. We'll check if the robot should turn left or right using the recovery mode variable. If recovery mode is left, we'll use the mbot2.turn API and pass in the turn angle as negative 90 degrees. This is because, according to the definition in the API docs, the angle passed in here will perform a clockwise turn, which means a right turn. This also means that to turn left, we have to pass in the negative value for the angle. Next, we'll check if recovery mode was set to right. In this case, we will use the mbot2.turn API again, but we'll pass in positive 90 degrees because we want to turn clockwise by 90 degrees. Once we've performed the turn, let's stop the program by exiting out of the while loop. The way we can do this is by using Python's inbuilt break statement. This will force the loop to end and we will fall outside the loop, stop all the motors, and end the program. I just realized that I have an extra period here after setting recovery mode to right. Let's remove that because that's a mistake. Save your program. And that's it for today's programming part. In the next video, we'll continue here. Instead of breaking out of the while loop here, we'll make the robot drive forward and then continue line following. For now, we'll leave it here for the coding part. So let's upload the code to our robot now. Make sure the robot is powered on and connected to your computer. Click Connect, select the COM port for your robot, and select Connect again. Click on Upload Code and wait for the robot code to be uploaded. Let's test it out on our mbot2 with our line follower sheet now. Start the program by pressing button B. The robot follows the line until it reaches the obstacle. It stops and waits. Now, since the line is on the left side of the robot, let's tilt the robot to the left and bring it back. We see the robot turn left 90 degrees as we expected. Now, we'll test the right side recovery mode. I'm going to make the robot follow the line in the opposite direction. It has now stopped after detecting the obstacle. Now that the line is on the right side, let's tilt the robot to the right and bring it back. We see the robot turn right 90 degrees. I'm going to repeat this on the left side so you get a clearer view. Great job today! I can't wait for you to complete the project by following along again next week. Stay tuned! If you found value in this video, Hit the like button and subscribe to learn as you explore for more MBOT 2 tutorials. Here are some of my other videos that you may find helpful. Happy programming, and I'll see you in the next one.